Okay, here is another example of simplifying radical expressions. Now in this case, this is going to be a little different. We have a fifth root of negative 9, multiplying fifth root of negative 27, multiplying fifth root of negative 243. Now before we get started, here's a fun fact. Every single time when you have any odd root, then it is okay to have a negative number or any negative number inside that odd root, okay? But if you have any even root, then no, it is not going to be possible. For any even root, you can only have positive numbers. But because this is an odd root, then for any odd root, it is okay to have a negative numbers, all right? Can we simplify fifth root of negative 9 and fifth root of negative 27? The answer is no, because negative 9 and negative 27 are not perfect fifth root numbers, okay? What does that mean? Well, that means that there is no smaller integer such that when that integer multiplies itself 5 times, we would get back negative 9. We don't have that type of integer. And the same thing can be said for negative 27. We don't have any smaller integer such that that integer multiplying itself 5 times would give us back negative 27. So negative 9 and negative 27 are not perfect fifth root numbers. So we can just go ahead and combine them together underneath one common fifth root, okay? But why is it that we get to combine these two negative numbers under one common fifth root? Well, because we only have multiplication between them, okay? Every time when you have multiplication and or division, no subtraction, no addition, you get to keep the identical roots of both of the numbers. And you multiply those two numbers underneath one common root, all right? So that is why I am able to have a common fifth root of the product of negative 9 and negative 27, okay? And negative 9 times negative 27, let's see. Well, that's going to be a positive number. 9 times 7 is 63. Right, 3 keeps 6. 9 times 2 is 18 plus 6 is 24. Okay, so we got a fifth root of 243. And we'll get back to this in a bit. Let's worry about a third one right here. Now, what about a fifth root of negative 243? Well, if you memorize a certain few perfect fifth root numbers, or if you have been working with fifth root for a little while, you would notice that negative 243 is actually one of the perfect fifth root numbers. Well, why is that? Because fifth root of negative 243 is actually equal to 3, because if we take 3 and we multiply 3 by itself 5 times, then, well, actually no, not 3, I mean negative 3. If we take negative 3 and we multiply itself 5 times, that's actually going to give us back the radical negative 243. Okay, so fifth root of negative 243 is equal to negative 3. We are going to have the fifth root of positive 243 multiplying negative 3. Well, earlier I said that if you have any odd root, that it is okay to have a negative number underneath. you know, in addition to the positive number, of course. Well, you have the fifth root of the positive 243 right now. Well, guess what? Instead of being equal to negative 3 like earlier, this is going to be equal to positive 3. The reasoning is because, same thing, 3 multiplies itself 5 times, just like in this case. It's going to give you back 243, okay? So this whole expression is going to be reduced down to 3 multiplying negative 3, which is equal to negative 9. And that is it. And yeah, so I do apologize for the mistake right here, but what I was trying to say right here is fifth root of negative 243 equal to negative 3, because negative 3 multiplying itself 5 times give us back negative 243. And the same thing can be said for the positive 243 right here. Alright, you guys, thank you for watching. See you guys next time.